Alright, so we are back now to check 7.1 Section 2's homework, which again I gave you 2 through 20 even. So we have these on the board here for you, and we'll just look at it. With this section, you're given premises and a conclusion. You have to figure out what's missing in order to derive that conclusion. So, for example, with number 2, we have if n, then s. Line 2, we need to figure out what would we need there in order to derive s for our conclusion. Well, our basic setup here seems to be a modus ponens. Right? If square, then circle. Square, therefore circle. The square is n. So n is what we would need to put there in order to be able to derive the s from lines 1 and 2 through a modus ponens. With the number 4, we've got C then H. We need to figure out what line 2 is in order to derive the conclusion of if R then H. Since the conclusion here is a conditional, we know we're looking at a hypothetical syllogism. So it's always helpful with hypothetical syllogisms to see them written out like this so that you get the right order. And we start here with the conclusion, which is if R then H. So that tells you that the square is R, the triangle is H. So the one we've got is C then H. The H is the consequent, which means that C is going to be the circle. So now we know if C is the circle, we can fill in this top line, and we see that what's missing is if R then C. Right? So if R then C, and so lines 1 and 2, hypothetical syllogism, would yield that conclusion. As usual, these start to get a little bit bigger as we go along. So now with line number 6, we have two premises. We want to reach the conclusion if A, then T. Well, we're going to use one of these with line 3 and get rid of the other one. Clearly, since the conclusion is a conditional, we're looking again at a hypothetical syllogism, which means that the disjunctive, the wedge, is irrelevant. So just like we did a moment ago, let's take that if square then circle, if circle then triangle, therefore if square then triangle. The conclusion is if A then T. So the square is A, the triangle is T. What we have is if A then W, so the A is the antecedent, so that means the circle here is going to be W. Once we know that, we know this circle is also W. So what's missing would be if W, then T. And so lines 2 and 3, hypothetical syllogism, would yield our conclusion. With number 8, we've got C or L, if L, then T, line 3, and then L is what we want to end up with. Well, very simply, we know that with a disjunctive syllogism, it's either one or the other. If it's not one of them, it has to be the other. Again, if you want to see it, square or circle, not square, therefore circle. So C or L, we want to end up with L, so we need to negate the C. So that's what would go in there, not C. And so lines 1 and 3, disjunctive syllogism, would give you your answer. With 10, we've got if H then A, if S then H, not M or H, 4, and then not H. So now we're going to pick one of these, get rid of the other two. The fact that you're looking at a negation here tells me we're probably going for a modus tollens. So let's draw our modus tollens form. If square, then circle, not circle, therefore not square. So not H. H is the square. So if we look, we have line 1, which has H as the antecedent. This one has H as the consequent, so we don't want that. That's a wedge, we don't want that. So we've got if H, then A is what's presented to us. So the circle is A, which means that what's missing would be not A. And so lines 1 and 4 through modus tollens would give you that answer. Number 12, G then C, M or G, T or not G, line 4, therefore G. This is very simple, another disjunctive syllogism, right? You've got On line 2, M or G. It's either M or it's G. We want it to be G, so obviously it can't be M. So what's missing is not M.